Okay, Algebra 2, this is section 6-7. It's about things called permutations and combinations. I know you don't know what those words mean yet, but you will. A permutation is an arrangement of items in a particular order. So we're counting the number of different ways that we can arrange a set of items. So the big phrase that you need to understand is that order matters in a permutation. Order matters. Now there's some other notation you need to see. Um, you might see this as, in the English world, as N. Right, emphasizing the exclamation point there. But in our world, that says N factorial. N factorial. Now, what does N factorial mean? It means you take the product of the integer and all of the integers below it. And I know this looks like I'm counting up, but I'm not. N times n minus 1 times n minus 2, all the way down till we get to the digits 3, 2, and 1. I'll give you an example, and it'll make a little bit more sense. 6 factorial, some people say 6. But 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. That's what 6 factorial stands for. And you get 720. We do have a... we can use our calculators for that. How many different ways can 10 dogs be lined up to groom? That's kind of a weird story problem. But in the first spot for the first dog to be groomed, we could put 10. There's 10 different dogs that could be put in that spot. But once we've chosen the first dog, then we only have 9 dogs to choose from for the second spot. The multiplication counting principle says that we can multiply all those things together. So that is 10 factorial. Now, can we find 10 factorial rather quickly on our calculators? Sure we can. We hit 10. We go to the probability button. And over here we have the factorial, the exclamation point. And when we do that, we can find out there's 3,628,800. Now, what if we had 10 dogs, but we were only choosing 3 of them? We only chose 3 to line up. So that means we'd have 10 dogs to pick from, but we only have 3 slots to fill. So we'd have 10 dogs that we could put in the first slot. And then once we chose that one, we'd only have 9 there. And then once we chose that one, we'd only have 8 left. So that's significantly less than 3,628,800. Right? That's 10 times 72. That's 720. Now, another way to see that would be 10 permutations, choose 3. So, and yes, our calculator can do that. But this represents the number of objects. Just put number of objects to choose from. And this would be the number of slots to fill. The technical definition for permutation looks like this. NPR equals n factorial over n minus r factorial. So 10p3 would be 10 factorial over 10 minus 3 factorial, or 10 factorial over 7 factorial. Well, 10 factorial is 10 times 9 times 8 times 7 times 6 and blah, 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 all the way down to 3, 2, and 1. Well, what's 7 factorial? 7 times 6 times blah, 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 3, 2, 1. Anything going to cancel out? Sure. Everything from 7 on down to 1, leaving you 10 times 9 times 8, which is what we just talked about. Now, I am going to have you write out the definition of the permutation. So you will need to write 10 factorial over 7 factorial. But your calculator will handle that, right? 10, and then you hit that PRB button again, you'll notice that the first one in the list is NPR, and then you can tell it that you have 3 slots to fill, and it will figure out 720 for you, but you will have to know the definition. Don't think you'll get away from it. So example 2, we have 7 yachts and 3 winners. Does order matter? It sure does. It would matter to me because I'm going to win a different amount of money. So order matters. That's why I'm choosing permutations. We'll have a different one called combinations in a little bit. But that's 7 factorial over 7 minus 3 factorial, or 7 factorial over 4 factorial. And what is 7 NPR 3? 210 different ways that we could arrange the winners. What happens if order doesn't matter? Whoa, a little bit too far. What happens if order doesn't matter? That's the question. Well, that's discussing what we call a combination, a group of items where order doesn't matter. Now, its technical definition, NCR, looks a lot like the original one, the NPR formula for permutations. It's got n factorial on the tops, it's got n minus r factorial on the bottom, but it's got this extra term, r factorial, in the bottom, which means that you're dividing it. Again, I hope that you understand that means that combinations are most of the time smaller than permutations. Most of the time. I'll give you an example. Here's the letters A, B, C. Now the permutations, ways to arrange those, there are 6 of them. Here, I've listed out all 6 of them. Combinations would say, well, that's the same group of 3 letters, so you can't call it something new by rearranging it. This is why my argument is against calling them locker combinations. If it's truly a locker combination, we should be able to take the 3 numbers and open the locker, no matter what order we put them in. But that's not true. If you switch the order, it matters. You can't open the locker. So we should call them locker permutations. I've been arguing for years about that, but they don't seem to care. Now, does 12C3, follow the same logic? Sure it does. We have a number of objects, but then this is the size of the group. It's not the number of slots to fill, it's the size of the group. So we have 12 factorial over 12 minus 3 factorial times 3 factorial. Well, that's 12 factorial over 9 factorial, 3 factorial. Give you a little bit of a hint. These 2 numbers are always going to add up to the number on the top. Always. And if you know anything about the commutative property, you'll also know that it doesn't really matter in what order you put them. But that's only for those of you who understand that. 12 PRB NCR 3 means that there are 220 different combinations. Now, when would be a situation where order wouldn't matter? Well, let's see. Example 4 says there are 20 books, and it says how many groups of 4 can be formed. I don't care what order you put them in. I just want to know how many groups of 4. So this is a 20C4 situation, or 20 factorial over 16 factorial 4 factorial. Remember, the two numbers on the bottom are going to add up to the 20 on the top. And 20 NCR 4 is 4,845. Our last example. There are 10 students running for 3 student government offices. 10 students running for 3 student government offices. How many ways can a person vote for 3 people? Remember, you don't have to vote for 3 people. You can vote for fewer. But let's suppose you voted for 3 people. In other words, we have 10 people, and we're choosing a group of 3 of them. All right, so let's see here. 10 NCR 3. 120. What if I chose to only vote for 2 people? Or 1 person? Well, I'm going to take my calculator. I'm going to go back up here. I'm going to change that to a 2. It's only 45. And just because I'm figuring this out, I might as well go back up here and change that to a 1. 10. Well, what about 0 people? Wouldn't that be 10 and I choose a group of 0? Well, that can only happen one way. You don't vote. Well, what about 3 or less? Well, that would be taking the 120 plus the 45 plus the 10 plus the 1, right? That would be adding all 3 of the ones that we found before. 120 plus 45 plus 10 plus 1 gives me 176 different ways that I could choose a group of 3 or less. Okay, we'll talk more about that in class. I know that it'll take a while for that to stuff.